In this video, we're going to use Pascal's triangle to aid in the process of expanding a binomial. You can see that this would be quite a process, x plus z to the fifth power. It would take quite a long time, but Pascal's triangle is an aid in helping us do it in less time. But before we begin expansion, I want to explain Pascal's triangle. First, you start out with a 1 at the top, and 1s are all along the side, as you can see. The next level right here, this 2 came from the result of these two 1s being added together. So you add the numbers above it to get to that number. So let's see how it works in this row. 1 plus 2 is 3. 2 plus 1 is also 3. And then again, your outside numbers are always 1. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. In this final row, we have 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then our outside number of 1. This pattern could continue on indefinitely, but we're just going to stop there. Now, when you number the rows, you always start out with the top row is row 0, and you count down. So this is row 1, 2, 3, 4, 5. If I wanted to expand this polynomial or this binomial, what I would do is I would look in row 5. Well, I know it sometimes gets confusing when you look at the top row and you see this is row 1. You want to call that row 1. So here's a little hint at how you can get this very quickly. See these numbers right here go 1, 2, 3, 4, 5. This 5 will match with the exponent right here, so you know it's going to be this row. So we're going to start simply by taking these numbers and writing them out vertically next to the problem. So I'm going to have 1, 5, 10, 10, 5, 1. I'm going to start with the first term in this binomial, and I'm going to start with a countdown. Again, I'm going to start with x to the fifth, x to the fourth, x cubed, x squared, x to the first, and of course x to the 0 power. We know that anything to the 0 power is equal to 1. So as you progress through these problems, it's really not that necessary to write that 0 power. But I'm just doing that to demonstrate the countdown. In like manner, the z is going to count up. So we're going to start with 0, z to the first, z squared, z cubed, z to the fourth, and z to the fifth. Now, again, you can see the pattern here. You're multiplying all these together. What you want to do next is simplify each row. Well, I can remove this 1 and this z to the fifth, so I'm going to have x to the fifth. And this is going to give me 5x to the fourth times z. This row will give me 10x cubed z squared. This row will give me 10x squared z cubed. And this row will give me 5x z to the fourth. And finally, in this row, I can remove this 1 and this x to the 0 because they're both equal to 1, and that gives me z to the fifth. What I also want you to notice in this pattern is that the sum of the exponents always add up to the number that you're expanding. So you have the 5, you have the z to the first, that's 5, 5, 5, 5, and 5. So that's another thing about this pattern that makes it very unique. Now, of course, you don't want to leave your answer in vertical form, so the last step here is just rewrite your terms and in a horizontal format. So we're going to plus 10x cubed z squared plus 10x squared z cubed plus 5x z to the fourth plus z to the fifth. And that is your final answer. And that took very little time compared to what it would take to multiply all that out separately. Next, we're going to do number 42 in like manner. Now, I'm going to admit that this would be much easier to do just boiling it out. But just to practice this pattern, let's just go ahead and look for the row with a 2 in it. So that's going to be 1, 2, 1. I'm going to write this down 1, 2, 1. And again, I'm going to start with this one, and that's going to be 1 squared times 1 to the first times 1 to the 0, and you can see that's all going to equal 1 as well. Now here's the tricky part, is this t right here in this negative. So that's going to be times negative 2t to the 0 power and times negative 2t to the first power times negative 2t squared. And then when we simplify each row, these ones can disappear, and actually this is also equal to a 1. So when you multiply those 3 ones together, you get 1. And 2 times 1 times negative 2 is negative 4t. And then finally you're going to have 1 times 1, and then negative 2t, quantity squared, is equal to positive 4t squared. So if you take now and write these in a horizontal format, you're going to get 1 minus 4t plus 4t squared. And you may want to just reverse the order there, because we like to see our polynomials written in descending order. Make sure the preceding sign there stays the same. And that is what you would get if you were to multiply out these two binomials together. And that concludes this lesson.